The next topic is mole concept. That is mole concept. The most important topic of this unit. Before mole concept, we have to knowledge about the atomic mass, molecular mass, molar mass. First, atomic mass is defined as the sum of number of proton and number of neutron present in the nucleus of any atom. That is known as atomic number. That is known as atomic mass. Atomic number या mass number is also known as atomic mass, the sum of number of proton and number of neutron present in the nucleus of any element. For example, nitrogen having atomic mass 14, oxygen having 16, carbon having 12. This is the atomic mass of nitrogen, oxygen and carbon. It means atomic mass and mass number is defined as the number of proton and number of neutron present in the nucleus of any atom. Next is molecular mass. Molecular mass. What is the molecular mass? These are the element, here we can say these are the atom. Whenever any atom combines with another atom, how the molecule formed? Then oxygen, when combined with second atom of oxygen, then the formation of O2. When oxygen combined with oxygen, then the formation of O2. And this O2 is known as a molecule. This is known as molecule. And this is known as atom. This atom having mass 16. This atom having mass 16. Whenever these two atoms combine with each other, then the formation of a molecule which having the molecular mass. That is 32 units. That is 32 units. Is it clear? Atomic mass is the mass of proton and neutron present in the nucleus of any atom. Molecular mass. What is the molecular mass? The sum of atomic masses of each atom, each element present in molecule. Is it clear? Means molecular mass is the sum of atomic masses of each element that is present into the molecule. For example, if I am having methane having the formula CH4. Methane having the formula CH4. I am writing the name here, that is methane. Methane having molecular formula CH4. This is the molecular formula. This is the molecular formula of methane. Then we have to calculate the molecular mass. Carbon having mass 12. Hydrogen having mass 1. We having 1 carbon, that is 12. Plus we having how many hydrogen? We having 4 hydrogen. And each hydrogen having atomic mass 1. Then 12 plus 4, that is 16 unit mass. Then you can say AMU, you can say gram. Because whenever we are measuring the mass, that is in gram or unit. Next, another example we are taking, that is NH3. This is ammonia. How can we calculate the molecular mass? Nitrogen having atomic number 7. Atomic mass is 14. Each hydrogen, one hydrogen having atomic number 1. Atomic mass is 1. Then we having 1 nitrogen having atomic mass 14. Plus we having 3 hydrogen. Each hydrogen having atomic mass 1. That time 14 plus 3, that is 17 unit, is the mass of 1 ammonia. Again, CH3 COOH. This is known as the compound having name ethanoic acid. This having ethanoic acid. Can you calculate the molecular mass of this compound? Try. Molecular mass. Carbon having mass, atomic mass 12. oxygen having 16, hydrogen having 1. Then calculate the atomic mass of this. Calculate the molecular mass of this molecule. We having 1 and 2 carbon. 12 into 2 plus. We having 2 carbon, that's why 12 multiplied by 2. Hydrogen 3 and 4. 4 multiplied by 1 plus. How many oxygen is there? 2. 16 multiplied by 12 is 24. 4 plus 32. 2, 0, 3 and 5 or 6. 6 gram, you can say 6 units. Is it clear or not? To calculate the molecular mass of any molecule, we just sum up the all atomic masses of each element present in the molecule. We are taking one more example, H2SO4. Calculate the molecular mass of this compound. First, I tell the name of this compound. The name of this molecule is sulfuric acid. This is sulfuric acid. Okay. We having hydrogen having atomic mass 1. We having sulfur having atomic mass 32. We having oxygen having atomic mass 16. Then can we calculate? Yes. 2 multiplied by 1 plus sulfur having atomic mass 32 plus oxygen having atomic mass 16, that is multiplied by 4 plus 64 plus 32 plus 2, that is 4 to 6, 6 or 2, 8, 6 or 3, 9. Is it clear? This is the molecular mass. We calculated atomic mass. Okay. I am just writing some atoms with their atomic mass. Please always remember them. Hydrogen 1, oxygen 16, carbon 12, nitrogen 14, sulfur 32, oxygen then completed, carbon also completed, copper 63.5, chlorine 35.5, and sodium 23, oxygen, hydrogen completed. These are some elements. Always remember their atomic masses. They are very helpful for us. So, please calculate the atomic mass of, molecular mass of sodium hydroxide. This is sodium hydroxide. Sodium hydroxide. Okay. Sodium having atomic mass. What is the atomic mass of sodium? That is 23. Oxygen having 16. Hydrogen having 1. Then what is the atomic molecular mass of NaOH? That is 6 or 3, 9, 0, 2 or 3 and 1, 4. 14 gram. You can also write unit. Okay. I think you can calculate the molecular mass easily of any molecule. The next thing is how you can calculate number of moles. Okay. First I tell you the number of moles. Number of moles means how many number of moles. For example, whenever we say I am having 1 dozen of books, that means that contain 12 articles. If I am saying I am having 1 dozen of markers, that means that contain 12. 1 mole is the measurable quantity for the particles, for the atoms, for the ions. To calculate the number of moles, we have to first knowledge about the 1 mole. 1 mole. There is a scientist that is having name Avogadro. That give us a specific value means 1 mole contain 6.022 into 10 to power 23 particles, ions or molecules. Also, atoms. Okay, means the first Avogadro number. We can say this is 1 mole also is equal to Na. Na is known as Avogadro number. Avogadro number. That having 6.022 into 10 to the power 23 particles, ion molecules or atoms. This is the major quantity. You can say that 1 mole describes us about these number of particles. But he also again tell us about 1 mole also is equal to molecular mass of any molecule. Molecule means 1 mole is equal to molar mass, molecular mass of any molecule, or atomic mass of any atom. Atomic mass of any atom means we can say molecular mass of any molecule and atomic mass of any atom contain 6.022 into 10 to the power 23 particles, ions, yeah, molecules or atom. I'm just giving you example to explain this. I am having H2, hydrogen gas. Hydrogen gas is a molecule. It having the molecular mass 2 gram. It having mass 2 gram. 2 gram means this is the atomic molecular mass of this. It means this is the mass of 1 mole. This is the mass of 1 mole, and this mass, that is 2 gram, contain 6.022 into 10 to the power 23 hydrogen molecule. Hydrogen molecule. Are you getting this? That 1 mole contain this number of molecules of hydrogen, and this 1 mole contain 2 gram mass of hydrogen molecule. It means we can say the molecular mass of any molecules contain the particle is 6.022 into 10 to the power 23 molecules. I am again taking more example O2. O2 having the molecular mass 32 gram, because one oxygen atom having the atomic mass 16. We having two atoms having the atomic molecular mass 32 gram. This 32 gram represent 1 mole. This represent 1 mole, because I am writing here the molecular mass of any molecule is equal to 1 mole. And this 1 mole again is equal to 6.022 into 10 to the power 23 oxygen molecules. I think you get the point. Means whenever we are taking any molecule, the molecular mass of that particular molecule always contain this number of molecules. Again I am taking one more example. I am having sodium atom. Sodium atom having the atomic mass 23 gram, and this 23 gram of sodium atom is equal to 1 mole. If it is equal to 1 mole means this sodium atom in 23 gram of mass contain 6.022 into 10 to the power 23 sodium molecules. Okay, 1 mole is equal to, as you know, that is 6.022 into 10 to the power 23 particles. Particle means ions, that can be molecules, that can be atoms. 1 mole is given by the Avogadro. Avogadro means this number. 6.022 into 10 to the power 23 is known as the Avogadro number. 1 mole also equal to the molecular mass of any molecules and atomic mass of any atom. I am taking some example, that is hydrogen having the molecular mass 2 gram. If it having the mass 2 gram, that means it contains 1 mole. If it contains 1 mole in 2 gram, it means it contains 6.022 into 10 to the power 23 hydrogen gas molecule. Again, I am having oxygen molecule. Oxygen molecule having the molecular mass 32 gram. If it having 32 gram molecular mass, that means it contains 1 mole, and 1 mole always contains 6.022 into 10 to the power 23 oxygen molecule. Okay. Sodium having the atomic mass 23, and 23, if it having the 23 mole atomic mass, that means it contains 1 mole. If it contains 1 mole, it means it contains 6.022 into 10 to the power 23 sodium molecules. Okay. Okay. Now we try to calculate number of moles, number of particles. How we can calculate these? Okay. First, we calculate number of moles. Number of moles. I am not taking so much time. I am just giving the direct formula to calculate the number of moles. Number of moles is equal to given mass divided by the molar mass. Divided by the molar mass. Molar mass means mass of one mole molecule. Given mass is represented by small w and molar mass is represented by capital M. W is known as the given mass, that is small w, that molar mass is represented by M. For example, if question is calculate the number of moles, calculate the number of moles in 4 gram of NaOH molecule. The question is that calculate the number of moles in 4 gram of NaOH molecule. आपके पास 4 ग्राम NaOH molecule है and you have to be calculate the number of moles. As you know the formula, number of moles is equal to given mass. In this numerical, the given mass is 4 gram. So W is 4 gram. But molar mass is mass of 1 mole of molecule. 1 mole of any molecule. And it having unit gram per mole. Molar mass can be calculated as sodium NaOH, we having sodium having 23, oxygen having 16 mass and hydrogen having 1. This is the mass of 1 mole of NaOH, that is equal to 40 gram per mole. So the number of moles is equal to W upon M. That is equal to 4 upon 40. This is 4 gram divided by 4 gram per mole. Gram to gram cancel out. It becomes 0.1. It means the 4 gram of NaOH contain 0.1 mole of NaOH. I think it is clear. I am taking one more example. Calculate number of moles in 34 gram of ammonia molecule. Calculate the number of moles in 34 gram of ammonia molecule. Try to calculate. So W is, in this numerical we have W, the given mass is 34. So molar mass is equal to capital M is nitrogen having atomic mass 14. Each hydrogen having 1, we having 3 hydrogen, that is 17 gram per mole is the molar mass of ammonia. The number of moles is equal to 34 gram divided by 17 gram per mole. This is 2 gram to gram cancel out and it is equal to 2 mole. I think this is clear for you. I am giving some questions with this. You can calculate after this. This is second. Third, calculate number of moles in 4 gram of N2O, 7 gram of nitrogen atom. Fifth question is 10 gram of calcium carbonate. Calcium having atomic number 40. atomic mass 40, carbon having 12, oxygen having 16. One more question is calculate the number of moles. You have to calculate number of moles in 4 gram of O2 molecule. Okay, I think you can calculate. You have to understand these two questions. There is a difference between, if I am writing O2, O2 is a molecule, N2 is also a molecule, Cl2 is also a molecule, F2 is also a molecule. All these are considered as molecules. And they having molecular mass, this having 32, this having 14 plus 14, that is 28. If I am writing nitrogen atom or if I am writing oxygen atom, it means I am just counting the separate nitrogen and I am counting only oxygen. Means this time we consider its atomic mass, not consider the molecular mass. It having the atomic mass 14 unit, it having the atomic mass 16 unit. I think all these things are clear to you. You can note down all these. Next we come to number of molecules. Next we come to the number of molecules. Number of molecules. Simply I am giving again the formula, that is number of moles. Number of moles multiplied by 6.022 into 10 raised to power 23. That can be ions and molecules, whatever we have. Again the formula becomes W upon M, and this is known as Avogadro number, that is Na. We can find out the number of molecules by this formula. For example, I am having a example. Calculate number of NaOH molecule in 4 gram of NaOH. Please be concentrated here. You have to calculate the number of NaOH molecule in 4 gram of NaOH. You having 4 gram of NaOH. We having formula to find out the number of molecules is number of moles multiplied by 6.022 into 10 raised to power 23. To find the number of moles, we have a formula given mass divided by the molar mass multiplied by Avogadro number. So, in this formula, in this numerical, we have W is 4 gram, and we already know that the molecular mass, the molar mass of NaOH is 40 gram per mole. That is 40 gram per mole. Okay. Then the number of molecules is equal to 4 upon 40 multiplied by 6.022 into 10 raised to power 23. Okay, this is 10 and it becomes 22. Okay, and again writing. Again I am doing the same. This is 4 by 40. I am putting all these in this formula. Number of moles is equal to given mass divided by 40 multiplied by 6.022 into 10 raised to power 23. 4 tens are 40 and this 10, this is 23, cancel out and it becomes 22. The number of molecules in 4 gram of NaOH is 6.022 into 10 raised to power 22. I think clear? Sure? Okay, I am giving one more example. Second, calculate number of molecules. Calculate number of molecules in 10 gram of calcium carbonate. Try. Yeah, how can you calculate? Calcium having atomic mass 40, carbon having 12, oxygen having 16 multiplied by 3. This is 48 plus 12 plus 40. 8 or 2, 10, 0. 4, 5 or 4, 9, 9 or 1, 10. This is the molar mass, 100 gram per. Okay. We have to find out the molecules. Molecules having the formula. This one, that number of molecules is equal to given mass, that is W, divided by molar mass, multiplied by NT. Is it clear? Clear or not? Okay. W is how much? 10. Divided by 100. Multiplied by NA having the value. NA having the value 6.022 into 10 to the power 23. Cancel out. And this cancel out this is 22. 6.022 10 to the power 20. Is it clear? Okay. Now the next question arises. Please थोड़ा ध्यान से सुनना और समझना इस चीज को. I am having calcium carbonate. And how much amount of this? This is 10 gram. Then this 10 gram I am having 6.022 into 10 to the power 22 molecules of calcium carbonate. My question is how many atoms of oxygen in calcium carbonate? How many atoms of oxygen in calcium? We are just saying 3 atoms. This is a 3 atom. In this, how many atoms of oxygen in Ca? This is a 3 atom present in one molecule. And how many molecules of calcium carbonate? 6.022 into 10 to the power 23. Again understand. I am asking the question, how many atoms of oxygen in calcium carbonate, or which calcium carbonate which having 10 gram mass? Again repeating the question. How many atom of oxygen? How many atom of which oxygen in calcium carbonate, or कौन सा calcium carbonate that contain 10 gram? You know that in 10 gram of calcium carbonate, how many calcium carbonate molecule? That is 6.022 into 10 to the power 23. Means 10 gram of calcium carbonate contains 6.022 into 10 to the power 23 molecules. Yes or no? हमने अभी निकाला है. And now I am asking that how many oxygen atoms? If one molecule of calcium carbonate contain 3 atoms. Clear? That 6.022 into 10 to the power 23 molecules of calcium carbonate contain 3 multiplied by 6.022 into 10 to the power 22. If I am multiplying that is 6.018. Okay. This is 10 to the power 23. Okay, I am just again writing. If I am multiplying 3 2s are 6, 3 2s are 6, 0, 6 8s are 18, and point is here. That is 10 to the power 22. If I am writing in scientific notation, the pointer, the digit, the pointer, decimal point should become after the first digit. That is 1.8066 into 10 to the power 23. Because I move 1 point. Whenever we come from 1 point right to left, that time we add 1 digit to 10. Is it clear? Okay. Next question is, calculate number of atoms of calcium in 10 gram. Again I am starting from that point. If you have any confusion, then clarify it. Calculate the number of molecules in 10 gram of calcium carbonate. Calcium carbonate 40 is the atomic mass of calcium. Carbon having 12, oxygen having 16. 16 multiplied by 3 because the calcium carbonate contains 3 atoms of oxygen. 40 plus 12 plus 48. That gives you the 100 gram per mole. For finding the number of molecules, we have in the formula formula: given mass divided by the molar mass multiplied by Na. The given mass is 10, the molar mass is 100 gram per mole, that is multiplied by 6.022 into 10 to the power 22. This is the molecules. This is the molecules of calcium carbonate present in 10 gram. I ask one another question to you, that is, how many atoms of oxygen in calcium carbonate having the mass 10 gram? Okay. If 10 gram contains 6.022 into 10 to the power 23 molecules, you get the point? I am saying that in 10 gram, how many atoms of O3, how many atoms of oxygen present? So one molecule contains 3 atoms. So 6.022 into 10 to the power 23 contain this much. I think this is clear. I am giving one more example to you for this. Calculate number of hydrogen atom in 51 gram of ammonia. My question is, calculate the number of hydrogen atom in 50 gram of ammonia. We have to calculate how many molecules of ammonia present. Whenever we read the question, first we have to find out how many molecules of the given molecule we have. We have 51 gram of ammonia. Okay, and this ammonia contains 3 atoms. Yes or no? I am having 51 gram of ammonia. Okay. First we find out the number of molecules in 51 gram of ammonia. Number of molecules is equal to how much? W, that is the given mass, divided by M, that is the molar mass, multiplied by 6.022 into 10 to the power 23. W is the given mass is 15. How can you find out the molar mass? Easy. Molar mass of ammonia. Nitrogen having 14, one of hydrogen having one atomic mass. Then we having 3, that is 17 gram per. Is it clear? Divided by 70, multiplied by 6.022 into 10 to the power 23. Cancel out 3. It becomes 6.022 into 10 to the power 23 multiplied by 2. It becomes is equal to 1.8066 into 10 to the power 24 molecules. If 51 gram of ammonia contain this much molecule, then how much atom present of hydrogen? Okay, 1 mole of ammonia, yeah, 1 molecule of ammonia contain 3 atom of hydrogen. Okay. We have 1.8066 into 10 to the power 24 molecules of ammonia contain 3 into 1.8066 into 10 to the power 23. Is it clear? This is the way to find out the number of molecules. Clear? Okay. One more example. How many OH negative ions in 1 mole of NaOH? How many OH negative ions present in 1 mole of NaOH? Okay. How many OH negative ions? NaOH is contain Na positive plus OH negative. Means 1 mole of NaOH contain 1 mole of OH negative. Yes or no? 1 mole contains 6.022 into 10 to the power 23 of NaOH. Then It contains 6.022 into 10 raised to power 23 molecules. Molecules, yeah, ions of OH negative. Is it clear? Next, you try to calculate 4 gram of NaOH contain how many ions? How many ions? So, how can we calculate? To calculate the number of ions, first we calculate the number of molecules, that is equal to point W upon M into 6.022 into 10 raised to power 23. W is 4, molecular mass is 40, multiplied by 6.022 into 10 raised to power 23. 1 by 10, that is equal to 6.022 into 10 raised to power 22 molecules. I think there is no doubt till this point. But question contain how many ions? How many ions? Ions means which contain positive or negative charge. Ions meaning the atom contain charge, or the charge can be positive or charge can be negative. The charge can be positive or charge can be positive, can be negative. Okay, I am having NaOH. I am having NaOH. NaOH contain Na positive plus OH negative. How many total ions present in 1 mole? There is two ions present. Okay. If 1 mole contain 2 ions, so how many particles? That is multiplied by 2 into 6.022 into 10 raised to power 22 ions. Again I am repeating. Ion means the number of atoms contain charge. Atom contain charge that can be positive, that can be negative. If I am having NaOH having Na positive plus OH negative, total number of ion is 2 in 6.022 into 10 raised to power 22. That is multiplied. This much molecules we having in 4 gram of NaOH. I think this is clear. No any doubt?